For that question number 3A, I did forget about the hole. There was a hole at -1 3/4. So somewhere, in around here, there is a hole there, and that coordinate is at -1 and +3/4 as the y coordinate. Okay. Now the scaling's not that great on here, but these are the details. As long as you can show those details, that's fine. For question C, I'm going to do C down here, but it's f of x is equal to x minus root x. Let me just double check that. X minus root x. Okay, so I want to find the zeros for this. Okay, so that my zeros are at x equals 0 and x equals 1. Okay, so I've got the zeros. There's no asymptotes or anything like this. There is some restrictions. Okay, my domain is from 0 and bigger. Okay, so I have to be considerate of that. There's an endpoint on this graph. And then if I do a limit as x goes to infinity, this graph will go to infinity. Okay, so there's some points here, so I'm just going to briefly sketch those in before I do the rest of it. Okay, so I've got zeros here and here. Okay, that 0 happens to be my starting point. Okay, so I want to find any mins or maxes, so I'm going to look for f prime. So f prime x is going to be 1 minus 1 over 2 root x. I want to find out where that's equal to 0. So I end up with root x equals, that looks like it's equal to 1/2. So I get x equal to 1 over 4. And that makes the y value equal to, when I plug it in, so it's going to be 1/4 minus 1/2. So the y value ends up being -1 over 4. Okay, so we're going to have some minimum point somewhere around there. Okay, so that's going to be 1/4, and that second 0 is at 1. This is at 1. Okay, I should do a slope chart here, so I forgot to do a slope chart for the last one. I have my x is 1 over 4. It's equal to 0 here. I can test my slopes. Okay, when I plug in a number that is smaller than 1/4, I'm going to get a number that is negative. Okay, that's 0. And any large numbers, okay, that's going to give me a really small big denominator, which is going to give me positive slope. So it's going to look like that. So I know that it's going to go down and up. I could check for some inflection points as well. Okay, my inflection points, I don't think there are any for this graph, but if I do a second derivative, I can differentiate this. I get negative 1/2. This becomes x to the power -3 over 2. Okay, so this is -1 over 2 square root x cubed. This is always going to be negative, so it doesn't look like the second derivative is going to, just double checking here, -1/2 derivative. Oh, sorry, that's going to be, yeah, I forgot that. Okay, so that's going to be 1/2. I should redo this actually. It's going to be 1/2. -1/2 is my coefficient. -1/2 is the power. And then I end up with power like that. Okay, so my derivative ends up being positive 1/4 and root x cubed in the denominator. So this is always positive. So that means we have a concave up situation. So if we look at our second derivative, okay, so there's our first derivative chart. Our second derivative chart indicates just a constant concave up graph. Okay, so there's a concave up graph, and so that point we've already established is a minimum, and we can just sketch our graph through that coordinate and up through there. It's going to go up through there like that.